The broadcast is now starting. All attendees are in listen-only mode.
Okay, welcome everyone to this meeting of the virtual CICS user group. I'm Trevor Eddles. I'm CEO of HTech. We're a mainframe consultancy, analysis and technical authoring organisation. We're the people responsible for the content on the Virtual CICS website, and we produce the newsletter. And we also look after the virtual IMS user group. So, first of all, I'd like to run through the agenda for this meeting. As usual, most of the meeting will be taken up with a presentation, and today our guest presenter is Russ Teubner. He's co-founder and CEO of HostBridge, and his presentation is called Putting CICS on the SIEM Radar Screen. A copy of the slides from this presentation will be on our website later today. And if you've missed any of our previous meetings, you can download copies of these presentations from our website too. And you can listen again to the whole presentations. And the links are all on the resources page of our website, which is fundy.com/virtual CICS. Following Russ's presentation and any questions you have for him, we'll move on to the latest CICS news and CICS related articles. Feedback request is there to remind me to ask you for your feedback about this virtual meeting. Then I'll give you the dates and times for the next couple of meetings, and that's the plan for today's session. I'm anticipating that it will last for just under an hour. Okay, so as I said, today's presentation is from Russ Teubner. Russ has been solving the difficult problems associated with integrating large-scale IBM systems and various emerging technologies for over 4 decades, he says. His pioneering work spans the integration of IBM mainframes and applications with Unix systems, TCP/IP networks, facsimile transmission networks, the World Wide Web, and service-oriented architecture. He's co-author of US patent number 6,981,257, which is all about XML enablement of CICS applications. And there are other patents pending. So, Russ, I'd like to thank you very much for being with us today. And what I'd like to do now is pass control of the meeting over to you. So let me do that now.
Great, Trevor, thank you very much. When you say 4 decades, it just seems like such a long time, doesn't it? Okay. Well, first of all, thank you, Trevor, for the opportunity to present today. Let me get my controls all positioned here correctly so we can see the slide. I can see the slide. But yeah, to everyone in the users group, thank you very much for your attendance today. I know that this is an important resource for CICS professionals around the world to stay up to date on what's going on with CICS. Not everyone gets to attend various trade shows or conferences that occur around the world in the CICS arena. So this is a valuable resource, and it's a privilege to be able to present here today. As Trevor indicated, I've spent my career focused on integration. And that integration between the mainframe and non-mainframe things has looked very different over the last 40 years. Originally, 40 years ago, we were focused on building technology that would allow large-scale mainframes to integrate with mini computers, the type of which were manufactured in those days by Digital Equipment Corporation, like a DECVAX 11780. Then we went through all sorts of eras, but today we focus on helping large organizations integrate their existing investments in mainframe-based systems and applications, typically with modern mobile web technology. Let me go ahead and advance the slide there. Okay, so I won't spend too much time describing us as a company. I think many people are aware, but for those who aren't, Our passion is all about high fidelity and what we would call precision integration for CICS and ZOS. We have a belief, and I suppose someone could prove me wrong, but I am not in doubt, and that is that poor integration to and with mainframe-based applications over the last couple of decades has been a primary cause of those applications becoming prematurely retired. Let me say that again. Poor integration is one of the top causes of, what would you say, death of good and valuable mainframe-based applications. Our cause over the last few decades, particularly in HostBridge as a company, has been to develop modern technology that allows high performance, high fidelity, and extremely precise integration to and with CICS-based applications. You can see some of our values here. We love to exploit what's already in the box. We stay up with what's going on with CICS. So even in today's presentation behind the scenes, I'll make note of some of the new features that we're using within CICS, such as event processing. We also believe in leveraging industry standards. There's just no reason to reinvent a good wheel these days. But really what we like to do is innovate and do the hard stuff. We're also known for our ability to integrate to and with CICS terminal-oriented applications without any screen scraping, which is still surprisingly relevant. Anyway, let's move on. I guess everyone has to have an obligatory slide where we show some of the customers that we have the honor of serving. These are some of them, but by no means all of them. We value our customers, and particularly the style of relationship we like to build with our customers is one of really listening well. Every good feature, every great feature that we've put in our product line over the past 20 years has come from a customer really expressing a request or describing to us a business problem, and we love that opportunity. In fact, even this one we're going to go showing you today came up in the context of a number of different customer interactions. So let me jump in and describe what we call it Hstack. And it stands for the HostBridge Transaction Analytics Connector. Now, I want to be, through this demonstration, very precise as to what this is and does, because I don't want you to see this, first of all, as more than it is, because this is a targeted strike at allowing CICS to be able to integrate it with these so-called SIEM platforms for the purpose of being able to get CICS activity on the radar screen, so to speak. So the formal definition is, and that is for enterprises with mobile, web, cloud applications, whatever, that are supported by CICS on the back end. That's who this is for. If you're running CICS applications on the back end, and that the workload is being driven by mobile, web, or cloud apps, then this may be for you. And specifically, what we do is we allow the SIEM platform to capture end-to-end analytic data. Now, I'm going to describe exactly what I mean by that in a minute. But what we're trying to do is address what we call what we think of as the visibility gap whenever CICS is in the radar screen, whenever CICS is involved. And as we've said, we want to put it on the screen. Now, I'll have another diagram to describe that in a minute, but let's tackle this word SIEM. I don't even think it's a word. I mean, no one really knows how to pronounce it. So we just kind of say the four letters as fast as we can and hope we get it right. So it stands for originally Security Information and Event Management. And the idea was to be able to have a tool that gathers together all sorts of structured and unstructured data to be able to create a collective dashboard for an organization to help them understand what's happening in the enterprise, whether it's for the purpose of security or just in general event and or business management. Splunk is an example of an SIEM. In fact, it's probably the leading example. Splunk is an extremely popular platform. It's not the only one. There are others. But we chose to focus initially on Splunk for one reason, and that is when we asked our customers, do you have an SIEM platform and what is it? The most dominant answer was Splunk. And so we thought, okay, we'll start there. So it is a leading platform. It captures, indexes, and correlates real-time data in order to create dashboards and visualizations of different types. It can be used for all sorts of applications, well beyond security and generic event management. Again, we recognize that Splunk is being used by a significant number of our customers. However, for most of them, Splunk and CICS have just never met. No one has really put those two sides of the equation together to really try to figure out how they might be able to create value together. So let's focus on kind of what happens and why and how we could create that value. The way that an SIEM platform is used today is that there's, on the left side of the screen, there's this whole universe of modern mobile and web-based applications, people doing things, flowing those across some sort of an infrastructure to a back-end application, maybe running on a server. And all of those components now are quite accustomed to contributing their event security and or event and application management information to a log stream such that it can be consolidated on a combined dashboard. So if without the mainframe in the picture, you have complete end-to-end visibility. The trouble is, what if some or even all of that back-end application logic is really hosted on the mainframe and running under CICS? What happens then? Well, what happens is that all of that activity just occurs off the radar screen. It doesn't appear because there's first of all nothing to correlate what's happening within CICS to what's happening on the distributed side, and then secondly, there's nothing that's actually contributing that data down to the SIEM platform. So there's really just a dead end right there, and that is what we were trying to solve. Now, clearly, those of us in the mainframe world, we know all about SMF records, and we can process those SMF records, and we can do things that are pretty cool. And some of those things we can even do in near real time. But that's good. But outside the mainframe world, these sorts of dashboards or products like Splunk are really gaining traction as being the high-level platform to really see what's going on end-to-end in the organization. So that's really where Hstack comes in. It's to complete that missing link. Now, again, we'll describe that in a little more in detail in a set of slides here in a second, but I just want for the moment to say that this is the general objective. We want to be able to make CICS contribute or cause CICS to be able to contribute its data to a platform like Splunk such that end-to-end correlation can be achieved. Now, one of my favorite new features of CICS that came along in recent releases, kind of started in the late version 4 timeframe and then grew and became more robust in version 5, is CICS transaction tracking. Now, what transaction tracking does is it provides a framework to correlate work that occurs inside of CICS, so that if transaction A starts transaction B and it starts transaction C, and you have this whole correlated workflow or sequence. What transaction tracking does is wrapper that entire flow as a transaction group and assigns it a unique transaction group ID. Now, in and of itself, that's really cool. The fact that now work can be aggregated, related work can be aggregated together, so that we can really know not just that transaction A, B, and C ran, but really it ran as part of a workflow. Now, again, that's really cool, but the problem is we see, or to really make value of that, to really gain value from that, we need to figure out how to associate that transaction group with what caused the work to be driven in the first place. So let's imagine that the work was driven by an HTTP or a SOAP request that came in from a business partner. Or let's imagine that it was a whole series of requests that came in via CTG, or maybe a socket-based application. How do we then associate that request with that transaction group ID such that when all the data comes to rest inside the SIEM platform, we can correlate it and determine in near real time both kind of the left side of the diagram where the request came from, and then the right side of the diagram which is all the things that happen under the covers of CICS that fulfilled that request. Now, very specifically, what Hstack does is we seek to be that bit of functionality required to form this connection between HTTP, CTG, or socket requests with the transaction group. So we are essentially enriching or augmenting the transaction group ID capability of this feature of CICS called transaction tracking. So what we'd like to say is that transaction tracking is great, but it's really a partial solution if what you really want to do is be able to correlate transaction groups with what caused that transaction group to be started in the first place. Now, Hstack is a evolving product for us. We're focused on expanding it quite aggressively. Our initial focus was on workloads sent to CICS via HTTP and CTG. Originally, we hadn't looked at sockets that much, but just in the past month, I spent some time working with a customer to explore the applicability to sockets, and turned out it was fantastic. So that's now on the supported list. We also focused on Splunk as the SIEM platform, although, as I said, there are others. We also wanted to create what we call an emitter, a very specific emitter for rapid POCs and project testing. But then we also partnered with SyncSort to ensure that our technology was compatible with theirs, so that SyncSort can be used for highly scaled environments, that should be SyncSort IronStream, used for highly scaled environments where it can deliver data down to the Splunk platform. So that's kind of our initial focus. Okay, every good CICS person loves a diagram, and if one is good, 7 are better. That's my theory. So here is a basic diagram that I've drawn that I believe encapsulates almost 90% of everything we see kind of out there in the world today. We have end user devices on the left side. They communicate through some sort of networking infrastructure. Then frequently they go through some sort of a non-mainframe app server. That middle tier is providing certainly the user interface and maybe some additional business logic. And then through one or another of a connector, whether it's CTG, HTTP, or socket, a work request is sent into the mainframe to CICS. And so now we move more to the right side of the diagram. And then that work request, let's say it's coming in through HTTP, will start a transaction. And then that transaction may start other transactions. Now, certainly in the case with our HostBridge product line, when you send a request into our JavaScript engine running under CICS, we can start any number of transactions, and we can orchestrate all sorts of workflow under the covers of CICS. So we certainly understand the need for this. But even if you don't use a product, an automation engine like HostBridge's, all of this transaction A starting transaction B, starting C, all of this orchestrated activity is likely still occurring. I'm going to use this diagram as the basis for now explaining Hstack in a bit more technical detail. The first thing I want you to notice is where Hstack runs. It's purely running on CICS. And what its sole purpose is to extract correlation data from the request and then enrich the data that transaction tracking manages. So that's our number one priority: extract correlation data and enrich what transaction tracking is managing. Then CICS transaction tracking automatically propagates that enriched origin data across all related transactions. So we don't have anything to do with that. It's magic to us. Now, the premise here, of course, is that we're going to contribute data out to the SIEM platform. So on the left side, you see non-mainframe components publishing their activity records, and we're going to assume that that activity record is going to include some bit of correlation data, and hopefully the same correlation data that was sent to the mainframe and extracted by CICS or by Hstack. Then, of course, we see the mainframe components publish their activity records, and that could be in the form of SMF 110 records, but they would also then include the user correlation data. Now, once the SIEM platform has all that, then correlation can be achieved between what goes on outside the mainframe and what goes on inside the mainframe. So we've already kind of just said that, or I should say redefined incrementally what Hstack is and does. Our job is to extract request correlation data and enrich the payload that CICS transaction tracking automatically propagates across all related transactions and automatically then includes in the SMF data, the 110 records that it creates. Now, I thought I'd throw a little more annotation on here just to describe how this request correlation data gets into the system. We'll start maybe up at CTG. There are a number of ways that request correlation data can be included. It can be in the COM area. Probably the easiest thing to do is just throw it in a different container, and then it can be Hstack can extract it. With HTTP, the HTTP architecture already has accommodations for being able to flow request correlation data through HTTP headers. So the to-do there is just use what HTTP offers. For socket requests, the request correlation data can be extracted from a couple of different data flows that are typically passed between the socket client and the standard CICS socket listener. And then with EXCI, it's really a model of CTG. Now, let's go down to the lower right portion of this diagram and consider this question. How is it that this data related to these transactions, these SMF 110 records for each transaction that have a common tran group ID and that have the enriched correlation data, how is it that they get to Splunk? Well, there are two ways that we actively support. And if you have your own roll your own mechanism for being able to move SMF data, we'd be happy to talk to you about that, and I'm sure we can probably work with it. But our two standard ways are using a set of functionality that's built into Hstack, or, as I mentioned previously, sync sort ironstream. The componentry that's built into Hstack is great, is purely CICS based. It's perfect for very fast proof of concept projects. We are driven via the XMN OUT exit, so we're picking up the essentially the monitor domain record before it goes to SMF, and therefore it is not subject to SMF buffering. So it is the ultimate in instant gratification. In fact, that's what I'll be using under the covers today. As soon as I run a transaction, immediately that data will be down in Splunk. But as I said, we also support IronStream, which is MVS based. It's perfect. It's a wonderful tool for highly scaled environments, and it's driven via SMF via a very configurable and flexible mechanism. Okay, with all that as prologue, I think what we'll do is move into a demonstration. Now I'm going to use that basic diagram one more time to show you what I'm going to be demonstrating today. And I apologize for the busyness of this diagram, but I'm obviously, exemplified by the orange box on the left where it says Russ. I'm sitting at a workstation. I'll be using a browser, and you'll see me using the browser. I'm going to be sending requests, HTTP requests, to our product running on the mainframe called HBJS. Now, I want to just be real clear about something right now. The fact that this demonstration is using HBJS should not in any way imply that Hstack only works with HBJS or other HostBridge products. Hstack will work with anything. Your application. In fact, I've spent the last 30 days focused with a company in the insurance sector to be able to install and implement Hstack with their a large, very complex insurance-based application, insurance industry application that has nothing to do with any other product that we as HostBridge produce. So again, we're going to be using HBJS purely because it's convenient for me. Now, as the activity is occurring on my browser, I'm going to be sending data to Splunk. Or on the network side. And then on the right side, as things are happening under the covers of HBJS, Hstack is going to take the correlation data and it's going to annotate the transaction tracking origin data. Transaction tracking is going to do its thing. It's then going to create a monitor record on its way to creating an SMF record. We're going to use the Hstack built-in emitter to be able to take the data right off the XMN OUT exit and ship it straight down to Splunk. So that's how we're going to get these two endpoints communicating down to Splunk. Okay, with that, let's go ahead and fire up the demo. Okay, now what you see here, let me just go ahead and reload it again, is an application that we wrote just to drive load on the mainframe. Now, this is actually an assemblage of 3 different IBM sample applications. In the upper left-hand corner is the trader application that's been around in kick circles for decades. In the lower left-hand corner is the what IBM refers to as the eGUI application that's been around slightly less time than trader. And then we have just some general DB2 activity going on in the lower right. Now, I can certainly go up here to this application and I can buy and sell things, and I'll just continue to do this to generate some load on the mainframe. Now, every time I do something over here in this upper left corner, I want you to see that right over here where I've highlighted, where it says trader, that is just a sequence of letters and numbers that are unique to that particular interaction. Now, so if I come over here and I say I want to buy 10 shares, you'll notice that changed. Same way with eGUI. If I come over here and I want to order something, then sure enough, the eGUI user data changed. Now, this string is the data that I have included in the HTTP header, and then Hstack will get it out, and then Hstack will cause it to be included in the origin data managed by CICS transaction tracking. So I would expect to be able to go over here, and I just switched over to Splunk. I am now looking at the basic Splunk event dashboard, and I'm going to, these are the most recent events. This just happened at 11:01:16. And you can begin to see that, yes, this is an event. This is all the data. I'm kind of committing overkill here. I'm sending all sorts of data from the monitor record down to Splunk. But you can see that the user correlation data is in fact, or I should say was sent by the client. Hstack grabbed it out of the request, caused it to be included in the transaction tracking origin data, and now when the SMF 110 data comes to rest down here in Splunk, we have not only the user correlation data, but we also have everything else about the transaction, such as the tran group ID. Now, we made a kind of a jump there. We went from our screen here. Of course, we're running these things on CICS, and now we jumped over to Splunk. I mentioned that this was the kind of the default Splunk screen, but the power of Splunk is really in its ability to create dashboards and analytics around all this data. So what we've done is, in fact, let me highlight two things. We have this this button here. I'm going to turn automation on, and all this is going to do is just automate a whole bunch of activities. So I'm driving load through HBJS, through CICS, and the essence is I'm generating a whole lot of data down to Splunk. So I'm going to go ahead, and I clicked on a link on that dashboard just to come over to Splunk and be able to see what's going on. So over here, remember, this is continuing to run, right? And now in real time, all of the user correlation data is being contributed to the CICS transaction tracking facility. Now all of that data is being sent down to Splunk, and we can kind of begin to get a basic idea of what's going on. And I'm generating a fair amount of load. It's only coming in from a single workstation, so it's not too excessive. But then I have designed this dashboard to where we can drill down a little bit. So what I did right here was I put together this dashboard to where I can click on that. We know that there were 42 get stock data scripts invoked, and now I can actually see them over time and what's going on with them. Or maybe I want to see what this particular transaction might be doing. And sure enough, I can kind of get a time chart of that. So now that we have a whole lot of data teed up, I'm going to go ahead and turn automation off, probably have enough, and we're going to explore what happened. So this, you'll notice that these particular bits of user correlation data also look like UR links. And so, in fact, they are. I can click on any one of those links and now go straight into Splunk and take a look at what actually happened there. So what this is describing is that bit of user correlation data, since it is shared on both the outside of the mainframe and on the inside of the mainframe, I can now affect correlation. So I know that it came from something called the demo client. I know that it executed a script. I know bits and pieces about the time and the duration or the response time to the client. But then I also know, because I have that bit of correlation data, everything about this mainframe or this transaction group running on the mainframe. So for example, I know where the request came from. I know the user ID. Obviously, I have the correlation data, which is allowing me to tie this together. And I know everything about the workload driven by this user, such as CPU time or whatever. But I also have a transaction group ID, so I can really drill down and see what actually happened. So I clicked on that, and it'll bring us to another dashboard where we can actually see what transaction occurred. Well, now this is not too interesting, but it's insightful. So here we had an HBJS transaction that did various things, and it looked like it ran one HBGP transaction. Let's go generate one that does a little more work. So let's come over here. I'm going to buy. I'm going to go ahead and execute all of those. And that's a little more complex transaction. So I'm going to get that bit of user data, and I'm going to come over here, and I'm going to go there. Now let's go see that transaction. We'll probably have a little more data to look at. Yeah, we consumed a little more. So here we are, HBJS, and we know the actual duration of the transactions that were in this particular transaction group. Then I can do things like analyze this a little bit more. So for example, again, because I not only have correlation, I know the user that caused this to happen, I also have a lot of data related to the transaction. So if I click on that bar right there, you'll notice that I am now displaying all the data that one might want to know just to get a summary view of the work required by that transaction. Now in doing this, again, the whole idea is to be able to create with a single dashboard a very high level view of what's going on inside a given transaction. So here's another one, the eGUI. I can click on that, and sure enough, I can see this transaction, exactly what's going on. Now this is a little more interesting. What this is saying is that the duration of the kind of the mother transaction, HBJS, ran for a given interval of time. And then it did in fact start 1, 2, 3, 4 iterations of eGUI. And you can see those laid out here in terms of transaction durations. It looks like this one was the high water mark. So let's click on that and go down here and just see some of the facts and figures about that. Now, by the way, the information that I'm showing on this dashboard is it's just what I decided what was interesting about these transactions. Hstack, I mean, we're happy to help you build dashboards that are meaningful to you, but the creation of dashboards is something that normally most organizations do themselves. We're not, strictly speaking, in the dashboard business. These are really, really easy to be able to put together and construct. So I don't want to mislead you thinking that the value proposition of Hstack, of Hstack, is that now you'll be able to see this particular dashboard. That would be underselling it. The value proposition of Hstack is that any application, regardless of what it might be, can be able to extract request correlation data from an inbound request, add it to the CICS transaction tracking data that it manages, and then have all of that information come out in an SMF 110 record or a monitor record, so that once all the data comes to rest in Splunk or a similar SIEM platform, that you can be able to do things like this. That's what Hstack is and does. It gives you the power to do this and create these sorts of end-to-end transaction tracking visualizations in your organization. Well, with that, I will stop. There may be some questions in a minute, so Trevor, I'll go ahead and allow time for that because it looks like we're running on time. Let me talk to you about pricing. First of all, availability. It is available now. We started availability in February of this year. We have sought to create a pricing model that is purely based upon the value that Hstack creates. we know from talking to our customers that the last thing you probably want is yet another software product that is charged to you based upon the size, the number of LPARs, the size of your CPU, how many MSUs or MIPS you have. So we took a fresh look at this and we said, the value proposition of Hstack is really based upon affecting those correlations. So whenever a correlation is achieved right here between Hstack for a given transaction, that's really where we create value. And you can completely tailor this. In other words, there may be, out of 100% of your load, you may only want to do this process, this correlation process, for 20% of your workload. Or maybe it's the other way. Maybe you want to do it for 80% of your workload, and 20% you understand really well, and you don't need to really see or visualize down in Splunk. Well, whatever that is for you, we have created a pricing mechanism that is geared toward that act of correlation, the actual work that Hstack does. If it's less than 1,000 a day, it's free. You can download the product. We'll give you a key. You're free to use it. And as you can see, as the daily volume of correlations goes up, the annual software license goes up as well. Now, if you really do want a perpetual license or an enterprise license or a CPU-based license, that's fine too. We'll sit down. We're reasonable people and we'll work it out. But we're just trying to experiment with a pricing scheme that doesn't rely upon CPU, the size of your mainframe, but instead is strictly correlated to the value that we create. With that, Trevor, I think I need a drink of water. I've gone through this pretty quick, so perhaps there might be some questions.
Yep, we have got 2 questions for you, so let's give you a second just to have a swallow of some water, and then I'll start on your questions.
Okay, I'm ready. Fire at will.
Okay, so does Hstack only work with HostBridge software?
That's a very common question, and we want to dispel that myth. Absolutely not. Hstack works with anything. So any application software that is running on your mainframe, whether it's from a third-party ISV, whether you wrote it yourself in-house, it's as long as there is, or I should say, as long as a request is coming in from one of these mechanisms, EXCI, CTG, HTTP, or socket, to start that workload, Hstack can be compatible with it. Last week or last month, for example, we spent some time, as I already alluded to, working with a very robust suite of applications from a company called Sapiens, and that run on the mainframe. And we were able to use Hstack with their product with no problem.
Okay, smashing. The next question is also from F. Johnson, who says, what versions of CICS are supported?
What we say is any supported versions of CICS we support. However, we strongly encourage you to be on version 5.1 or later. The difference is that in 5.1, IBM, through the life of version 4, IBM was adding additional fields of data to the monitor record related to transaction tracking. So in 4.2, they started adding these things like in 4.1, 4.2. Finally, by 5.1, it's settled. They haven't been adding anymore. And so we think that it's not only in customers' best interest to be on a version 5 release of CICS, but it also gives you the maximum amount of data that can be used for core purposes of correlation.
Okay, and lastly from Jan Moyersons, not really a question, more a comment, says, interesting, nice integration.
Well, thank you very much. We appreciate it very much. Our job is to build interesting things on behalf of our customers, and so we take that as a compliment. Thank you.
Okay, Ron Smith has just asked, if you have written your own socket listeners, are they supported?
Yeah, Ron, I'm sure we can, because I've written a number of socket listeners myself. It might require a bit of collaboration on our part. The best place to actually, for us to trap the user correlation data is when your listener starts what I would call the handler transaction. That, in fact, is exactly what we did with an ISV application from Sapiens. They used their own listener transaction, and so a request came in from WebSphere as a socket request. It flowed some data to their private listener, and then their listener started their handler transaction. And so what we did was, in that case, we had Hstack listen on the CICS event processing interface whenever the socket listener started the lead transaction of the transaction group. So the answer is yes, but there are a number of ways to do it, and we'd be happy to talk about it.
Okay, brilliant. If that's all the questions, if any more come in the next minute, I will ask Russ, but otherwise you can always email me, or I'm sure you can email Russ and they'll give you an answer.
Absolutely. My email is fairly simple. It's just Russ, RUSS, at hostbridge.com.
Okay, brilliant. All right, let me take back control. Right, okay, that's great. Well, yeah, thank you very much, Russ. As usual, then, can you assume that you're getting a virtual round of applause from all of us? So thank you very much. Okay, let's move on. News? Well, yes, again, there haven't really been any sort of CICS related news items, so nothing to report on that. But articles, there have been a few. So we've got Kick support for Eclipse Micro Profile 1.2 by Alexander Brown, and that's on Kick's Dev Center. And we've got Kick's Tools, a friend in your DevOps journey with Kicks by Kasturi Mohan, also on Kick's Dev Center. Kicks TG version 9.2 Fixpack 2 available now with support for Win 2016 by Janaki Sundar on Kicks Dev Center. The Kicks RFE process. What happens to my RFE by John Tilling on Kicks Dev Center. Extended support for EXCI channels and containers now available in Kicks TS 5.5 Open Beta, again by John Tilling. And workload management using Kicks Explorer Introduction by Stuart Francis, again on Kicks Dev Center. So that brings you up to date with all the articles. And of course the links to those are all on our website. As always, then, can I ask for feedback about this meeting? You can comment on anything good and anything you think we can improve on for next time. You can email your comments to me. The address is on screen, or you can go to the Contact Us webpage on our site. So, what's planned for the future? Our next meeting is on the 10th of July, and we've got Glenn Schneck, who's Senior Solutions Engineer at GT Software. He's going to be discussing from legacy to leading edge, creating Kicks APIs easily without coding. And the meeting after that takes us to the 11th of September, and we've got a speaker from Unicom presenting. Oh, and of course, social media. If you want to stay up to date with what's happening in the world of Kicks and on the virtual Kicks user group website, you can follow us on Facebook and Twitter, And we've also got a virtual CICS group on LinkedIn. And the URLs to all of those are on screen, but they're also on our homepage of the website. And just a reminder, that's fundy.com/virtual CICS. If you're tweeting, the hashtag is hashtag virtual CICS. And like everything in social media, we like likes. So if you're on Facebook, then come and like our page. Okay, well, that's all for this meeting of the Virtual CICS User Group. Can I thank you all for attending? I must thank Fundy Software. They're the people who sponsor this user group and make these meetings possible. And I'd particularly like to thank Russ Teubner for his presentation today. So that's it. Thank you all very much for joining the meeting, and I look forward to seeing you on Tuesday, the 10th of July. So thank you all, and goodbye.